Dear learners, our present discussion is on the physical significance of the gradient of a scalar function phi. Phi is a function of x, y, z. Before attending this lecture, you are requested to listen my previous lecture on the vector differential operator. It is a very important vector operator to define three important physical quantities: gradient, divergence, and curl. It is denoted by delta, inverted delta. Del equal to I del by del x plus j del by del y plus k del by del z. It is a vector operator. It possesses properties analogous to those of ordinary vectors. If we operate a scalar function phi, function of x, y, z, by this vector differential operator del, then the result is del phi is called the gradient of the scalar function phi. That is, the gradient of phi, grad phi, equal to I del phi by del x plus j del phi by del y plus k del phi by del z. Phi is a function of x, y, z. Phi is a function of x, y, z. Therefore, d phi equal to del phi by del x dx plus del phi by del y dy plus del phi by del z dz. Del phi by del x is the change of phi per unit change of x, and del phi by del x dx is the change of phi due to change of x. Similarly, the second term indicates the change in phi due to change in y, and so on. Therefore, total change in phi, d phi equal to del phi by del x dx, del phi by del y dy, del phi by del z dz. It can be written as I del phi by del x plus j del phi by del y plus k del phi by del z dot dxi plus dyj plus dzk. A dot B equal to ax bx plus ay by plus az bz. On that rule of expression of A dot B, we have written here the right side of d phi as follows. Which is equal to del phi dot dr. R is the position vector of the point where we are looking for phi and grad phi. R equal to xi plus yj plus zk. Therefore, dr equal to dxi plus dyj plus dzk. Let us choose a surface S where the scalar function phi function of xyz is constant c. Phi is constant over this surface. That is, d phi is 0 on this surface where phi is constant. Therefore, grad phi dot dr equal to 0. Grad phi is a vector which is perpendicular to dr. Dr lies in the surface, therefore we may say that grad phi is normal to this surface. In other words, grad phi is along the normal to the surface where phi is constant. Phi changes most rapidly in this direction. In other words, the direction in which phi changes most rapidly is the direction of grad phi. We may realize it from an example. We see an electric field E created by a point charge Q at a point O. We imagine a surface of radius r and the center at O. The electric potential V is constant over the surface. V is a scalar function. Its negative gradient at P gives us an electric field E along OP, that is, along the outward drawn normal to the surface at P. Therefore, E equal to minus del V, that is gradient of V. E is not negative, as delta V itself a negative, since V decreases with the increase of R. V decreases most rapidly along the outward normal to the surface and E acts along that direction. Thus, gradient of a scalar function, a scalar quantity phi, gives us a vector quantity grad phi. Physically, del phi is the rate of change of phi at the point P considered along the normal to the surface where phi is constant. Thank you.